In this video, we're going to answer the following question. A box has a large number of tickets with a number on each ticket in the box. The average of the numbers is 50 with a standard deviation around 10. 900 draws are made with replacement from this box. We want to estimate the chances of the following. First, the average of the numbers drawn will be greater than 51, and then the average of the numbers drawn will be between 49.7 and 50.3. Now this is an example of reasoning forward. We know the contents of the box. What we don't know is what our sample of 900 draws will look like. So what part A is really asking is what are the chances that the average in the sample is greater than 51. So first we want to figure out the expected value. When reasoning forward, the expected value is the average of the box, which we know. The expected value is 50, given in the problem. We also want to find the standard error. We do have a formula for the standard error. It is the square root of the numbers drawn, or I should say the sample size, divided by the sample size times the SD of the box. This can be rewritten as SD of box divided by the square root of sample size. These are equivalent using algebra. However, you are perfectly welcome to use this formula here. Well, we know the SD of the box is 10, and the sample size, I wrote 900, but let's use 400 here, is 400. Then the SE is 10 divided by 20, which is 1/2 or 0.5. You can solve this problem just as easily. Using a 900, the numbers just will not be as nice. We'd get the SE was 1/3 or 0.33 repeating. So that's the expected value and standard error. Now let's answer the question to part A, which is the average of the numbers drawn will be greater than 51. We go back to the normal curve. The center is the expected value, which is 50. And we want to figure out the chances that it will be bigger than 51. 51 is actually over here. What we really need to do is indicate that it's to the right of 50. So we want to convert to standard units using the expected value and standard error. 50 goes to 0. For 51, we take 51 minus the expected value, which is 50, divided by the standard error, which is 0.5. This ends up being 2. So we're looking for the area under the normal curve to the right of 2. Well, that is 100 minus the area between -2 and 2. You can look at this table here to figure it out, and it's 95.45%. Now that will give us the area outside of -2 to 2. To get the area to the right of 2, we divide by 2. So we have 100 minus 95.45 divided by 2, and we get 2.275%. Let's ignore this problem here. This will be in the next video. And let's move on to part B. We've actually done most of the work. We need to find the expected value and standard error in order to answer this question. So we can move right on to the normal curve. We're looking for the area between 49.7 and 50.3. First, draw the expected value, which is 50, then indicate where you think the 49.7 and the 50.3 are. They're the same distance from 50, so I'll try to indicate that here. Shade in the area we're looking for. And then we want to convert to standard units. The expected value always goes to 0. To figure out 49.7, we do 49.7 minus 50 divided by the standard error, which is 0.5. So we do 49.7 minus 50 divided by 0.5, and that gives us negative 0.6. We'll do the same thing for 50.3. Take the 50.3 minus the expected value, which is 50, divided by the standard error, which is 0.5, and we get 0.6. So we're using normal approximation, and we want to find the area under the normal curve between minus 0.6 and 0.6. We go to the normal curve table, look for 0.6. 0.6 is associated with the area 45.15%. So the area here is 45.15%, and that's actually what we're looking for. So that is our answer. The chances that the average in the numbers drawn, which is our sample, is 45.15%. Let me say that again. So the chances that the numbers drawn, and we're taking 400 draws from the box, that we get an average draw of between 49.7 and 50.3 is 45.15%. If you have any questions about this video, please ask in the questions and answers discussion board.